Hello students, let us try to understand the concept of phosphorus pentachloride. Right student. So phosphorus pentachloride is a halide, okay, of phosphorus. Let us see student. Phosphorus pentachloride is prepared by the reaction of white phosphorus with excess of dichlorine. So it is the limited dichlorine is there, it will give phosphorus trichloride student. But if it is the excess chlorine is there student, here you can see, so it will give the phosphorus pentachloride. You can see student, that is if you are white phosphorus, this is nothing but student white phosphorus. So if you are adding that is excess of chlorine, 10 moles of Cl2, say it will give that is 4 mole of PCl5 student. Also it can prepare from the action of thionyl chloride student. If I am having that it's P4 plus we are taking that is 10 mole of SO2Cl2 student, SO2Cl2. So it is also giving 4 mole of PCl5 plus 10 mole of SO2. So again it is giving what student, this is giving the PCl5 only. Okay, now let us look over the properties student. So PCl5 is alloys white powder and moist air. It hydrolyzes to POCl3. It hydrolyzes to POCl3 and finally get converted to phosphoric acid. Finally get converted to phosphoric acid. So firstly it is hydrolyzing student in the POCl3, and then POCl3 again reacting with water hydrolysis, and this is giving the phosphoric acid H3PO4. So this is what the this is in the moist air, it is undergoing the hydrolysis to phosphoric acid. Now the dear student, let us have a next one. It decomposes on heating. Okay, when heated is sublime, that decomposed on a stronger heating, PCl5 it will give that is PCl3 and Cl2. Okay, it react with organic compound containing NOH group, converting them to the chloro derivative. Like that is ethanol is there, it is reacting with PCl5, it is there, that is giving the chloroethane and POCl3. Yeah, the similarly it is also reacting with the acetic acid plus PCl5, it is giving the acid chloride CH3COCl and POCl3 plus HCl. Okay, now next one is finely divided metal on heating with PCl5 gives corresponding chloride. Like 2AgCl is there, 2Ag plus PCl5, it is giving the 2AgCl plus PCl3. Sn plus PCl5, it is giving SnCl4 plus PCl3. So this is how we are studying, that is the phosphorus pentachloride student. Now we are talking about the its structures. Okay, so if you talk about the structure of, you can see student, here is the, this is the trigonal pyramidal structure is there. PCl5 is having the trigonal bipyramidal structure, and in which you see axial bond is the 240 picometer. Because of the more repulsion student, here is 90 degree is there, so more repulsion, so more bond angle, more bond length, and less repulsion is the 202. So that is much smaller is the equatorial. This is the equatorial bond student, equatorial. Okay, and this is the axial. So axial you are saying student, this is longer because of here. Okay, I will explain it more again student. Let us firstly read out the topic here. It is used in the synthesis of the some organic compounds such as the chloroethane and acid chloride. Okay, in gaseous and liquid phase it has the trigonal pyramidal structures as shown. The three equatorial PCl bond are equivalent, while two axial bonds are longer than the equatorial bond. This is due to the fact that the axial bond pair suffer more repulsion as compared to equatorial bond. In the solid state, it exists as an ionic solid PCl4 and PCl6, in which the cation PCl4 plus is tetrahedral and anion PCl6 is octahedral. So here they are saying student, firstly they are saying that is it is having the trigonal bipyramidal structure. It is like that. So if you talk about trigonal bipyramidal structure is like that, here is Cl, okay, Cl, and if you in this one you are putting the pyramid on the top here, so it will be the bipyramidal. So here is Cl and this side Cl. Now student, this is the case. Okay, this is the case. Up here what happening is student 120 degree. Okay, what is happening here is 120 degree. What is happening here is 120 degree. So here is more bond angle, more bond angle means this bond will be, student, a small bond. No, this is the small bond, because bond angle is 120 degree. A small bond, how much? 202 picometer. अब now see, student, okay, this is how much, student? 90 degree. Because of 90 degree more repulsion. Okay, 90 degree, 120 degree, that is less repulsion, more bond, more repulsion, longer bond. So longer bond, if you talk about, student, this is longer bond, how much? 240 picometer. Okay, so this is axial bond is what? That is longer because of repulsion. And equatorial is, equatorial is what? That is equatorial bond is the, is smaller because of less repulsion. So this is all about the phosphorus pentachloride, student. Thank you so much for watching.